Black, and this is my presentation for the final Practicum 2 on Marvel vs. DC movies building a recommender system. I first want to start by apologizing that I am not in full screen mode. I only have one specific software that I can use on my laptop currently that allows me to do screen captures, and when I enter full screen mode, it likes to not do the recording at all, so bear with me. This is the best I can do. Again, my apologies. Whoops. Okay, so let's jump right in. Let's first go over what we're going to talk about a little bit in this presentation. I'm first going to address our problem statement, give you sort of an idea as to why I chose to build a recommender system for Marvel and DC movies. That will lead us straight into our research question. I'll then give you an overview of the data that I used and sort of some of the nuances with said data, then the methodology for our recommender, as well as our results, and then any final recommendations that comes out of the project. So the driving problem behind Marvel versus DC was really how the movie industries are competing so often for everyone always saying, oh, Marvel's better than DC, DC's better, Batman's best, Spider-Man's best. It's all based on personal preference and opinion. So what I wanted to do was see if there was a way to scientifically determine if a movie is actually better than another, and that's not really the case here, since you can't really scientifically prove that a Batman movie outweighs a Spider-Man movie. But what you can do instead is eliminate that personal preference in being able to select a movie. And so the goal of this project is to really be able to determine if it's possible to ignore your own personal opinion and your personal preference and say, oh, the Batman Returns was super cool, what other movies are similar to it, instead of just always assuming it's going to be another Batman movie or another DC movie to follow through that specific category. So that brings us straight into our research question, and the driving question for this is, can movie data predict better movies to watch than your personal preference? So as I was saying, is there a way to use data on a movie, such as IMDb scores, descriptions, even the genre or the title, to determine if you can find a better fit for the movie than just assuming all Batman movies will be the same, so you're going to like all Batman movies, or all DC movies were built the same and are in the same category, so you will like all DC movies. And so the sort of underlying analysis behind it will be, if you are looking at a Marvel movie, will we always recommend similar Marvel movies or other Marvel movies? Or will we find that DC movies will recommend just as often as Marvel movies, and vice versa? If you sent in a DC movie, will we always output another DC movie recommendation, or will Marvel movies also be outputted as well? So just going into an overview of the data, like I said, we're going to be looking at movie data that was collected through IMDb. The data source was brought to you by Kaggle.com. And this IMDb data set consists of our movie title, the year that the movie came out, genre such as action, rom-com, sci-fi, sometimes multiple genres at the same time, length of time of the movie, rating, director, actor, description, your IMDb score, as well as a Metascore, votes, gross profit, and category. And your category will be either Marvel or DC. Now, not all of these variables are going to be used in our recommender. Our recommender starts just by using the description, doing a text mining analysis on it, and going from there. We will also be using title of the movie and hoping to embed in IMDb scores as well. And so we have over here just a quick kind of overview of what our IMDb scores kind of look like, just to see where sort of our scores are kind of heavy meaned, if we have a specific score that's always appearing, and it looks to be that most of the movies score pretty highly amongst each other. They're all very grouped together, with a few in the lower left scores. So the ideal goal would be that those lower left scores will not recommend movies with higher scores, but the similar scored movies would recommend one another. So reviewing the data just a little bit further, I decided to look at how many Marvel versus DC movies there actually were to see if this was going to be kind of a fair recommender. And as it turns out, there's roughly 3 times more DC movies in our subset than Marvel movies. That is kind of an issue going into the start. It's definitely starts with a little bit of bias towards having more data on DC than it does on Marvel, so we'll see how that affects our recommender. And finally, just a few little nuances that are also going on with our data. As you see on the right side of the chart there, this is the spread of how many of those categories have no data entered into them. So our movie title has all of the movie titles filled in, which is a great thing. However, we are missing several of the year, runtime, rating, and director, which is fine since we're not really using that. Our descriptions are all completely filled in as well. But our IMDb score is missing 204, which is approximately 12%. And then going through less than 0.005% of the data, which I think that decimal point is actually in the wrong spot. Looking at the numbers now, I think it's supposed to be 0.05% of the data are missing genre. Anything that is missing entry, instead of removing that entry from our data set, I chose just to leave it in, so that way we weren't reducing it, since we only had 1,690 entries to begin with, which is a fairly small data set, considering how little number of Marvel movies we had. I didn't want to have to reduce that down any further. And the last thing, which feeds into our cleaning a lot, is the description. Although everything is filled in, it is lacking some actual driving information. Some descriptions of the movies just say like a plot or movie, and so that drove the data cleaning quite a bit by making sure plot, movie, some of those keywords that you wouldn't think need to be included in our stop word list needed to be included in a stop word list. So that really kind of drove that as well. Ideally, what the plan was going in, and what the plan is, I guess, is to first clean the data. So what we did was we constructed a new data frame with a subset of the variables that were going to be of use for the recommender. Then we were going to remove our stop words, edit that stop word list, as I said, tweaking it based on the description, and anything else that we noticed was always popping up a whole bunch. And then we did a lemmatized and stemmed reduction. I did choose to go with the lemmatized cleaning process instead of the stemmed words, and that was very apparent when you compare the two together. Our stemmed word process, or our stemmed reduction, ended up giving us a lot of half words and really text that made no sense. So when it fed into the recommender system, or when it fed into the clustering algorithm, it was very hard to follow and understand what was going on. And then also we made sure to remove all punctuation and special characters. That included, especially in the genre, removing a lot of commas and hyphens, and colons also from title. Once everything was all clean, then we would develop our k-means clustering algorithm, which took the variables, it took the text, transposed it to a vector instead of, so what that does is that removes the text sort of embedded into it and turns it into a numeric that we can cluster with. Run the cluster algorithm, then we did a sum of squares error to validate how many clusters were chosen. We refined the model based on that, and then went into the recommender from there. So the first go around kind of gives you an idea of what these clusters look like. I first chose 10 clusters on just the description. Every time I tried to use more than one variable, my clustering algorithm would just cluster on the headers and would not cluster on the words, or would always give me the same cluster no matter how many clusters I chose. And I chose all the way from 1 cluster up till 20 clusters just to see what happened. So When I first chose 10 clusters, here's sort of an overview of kind of what the clusters looked like, as well as the first plot is looking at the 30 first clusters and that sum of square error. Then once I realized that we sort of lost that consistency and it was hard to tell where that elbow kind of elbows off, for lack of a better term, I decided to reduce our sum of square error to just look at everything before the first 10. And you see it's more of a smooth curve down here. However, I was noticing that if you had any clusters from 7 onward, you always will return the same cluster no matter what title you input in. So if you looked at Batman, Spider-Man, and Loki, and the Avengers, and even like Wonder Woman, Batgirl, whatever, they all would return cluster 1, for example, no matter what. So everything was being clustered together. So what I chose to do was, I think I picked about 6. Yeah, because right at 6 here, that's where our elbow starts to, our curve starts to elbow more. Sorry, my brain is a little out of it today. So once we were able to develop our clusters after refining it, here's sort of our little tester to see how it worked. So what we did was we took a cleaned version of all the titles. So we weren't looking for those special characters or any capitalizations. We removed all of that out of it and just gave the basic title and filtered it in, just chose a random handful of titles in this first chart up here, and looked at the array as to where they were falling in line with our cluster. So we can see Loki, WandaVision, Black Widow, Iron Man all fall into cluster 1, whereas Batman falls into cluster 2, Spider-Man, Smallville are in cluster 1 as well, Supergirl's in cluster 3, and Catwoman is in cluster 1. And correction to my previous statement, I chose 4 for the number of clusters. And that was, again, based on that elbow curve. So then what I wanted to do was see if every time you looked at a Marvel movie, if another Marvel movie would be recommended, and likewise with the DC movies. So the way my data was set up was the first 100,000 and something columns were all Marvel movies, and then the last 2/3 or 3/4 were all DC movies. So I just decided to take the first 10 movies listed knowing that they were all Marvel, and the last 10 movies listed knowing they're all DC, and see if they kind of recommended only the same category of movie or not. And so you can see with our first 10 Marvel movies here, we did return only Marvel movies recommended. However, when we looked at our DC recommendations, we returned movies from all groups 1 and groups 3. So we can see that our clusters are not biased. They are not split up to be just Marvel movies, just DC movies, but that we have a nice skew of different movies will recommend different subsets in there. Unfortunately, there was some issues getting my recommender built and developed, so I was not able to get a nice wrapper that would, if you entered in a movie, it would give you the top 5 movies that are similar in that cluster. So that would be kind of my first formal recommendation, is moving forward to get that implemented so that way you can actually see the formal movies that are the most similar to the movie you recommend. My next recommendation would be to try and review with a more balanced data set, and also maybe using different sort of text mining techniques or variables when building the recommender, just because of how skewed the Marvel versus DC category was, and how it was about 3 times more weighted on the DC side. But really find a data set that kind of balances those out to make it a little more even and fair, for lack of a better term. And then see if you can actually build a clustering recommender with more than just the description. Again, as I was saying, I had several errors when I was trying to build my recommender and constructing my algorithm that would not allow me to use more than one variable. And that was just based on when we vectorized the text into the sparse matrix, it could only make one sparse matrix, and I found that the k-means clustering was having a hard time taking in more than just the one sparse matrix. And if we had a sparse matrix of all of the variables crossed within each other, then I was only allowed to use how many variables I had for a cluster. So if title, genre, and description were my headers, I was only allowed 3 clusters. And then also those 3 clusters, the top words in all the clusters were always movie, genre, and description. So that sort of factors into my very last bullet of I started doing some research these past couple weeks and learned that k-means is not always the best to build a recommender clustering algorithm, especially if you have multiple variables. However, the k-nearest neighbor can handle that, and there's several papers and studies right now that are actually trying to build a movie recommender using k-nearest neighbor. And that is because of it has that added accuracy and details that the k-means clustering has. And that is all. So thank you so much for stopping by and listening to my presentation. Feel free to ask me any questions if you have them. Thanks again.